supporting it. So even if you could enable it for you just for older cards, or if you could have enabled it like a year ago, you wouldn't have been able to meaningfully use it because nVidia needs to ultimately write the training frameworks just with like they did with FP8 training.
Yeah, that's true. But
So
I
the
think
software wouldn't have been ready anyway, even if they enabled it, and it would just nobody would have ended up using it, as most people didn't end up using FP8.
Yeah, they didn't use it much for training, but basically all commercial inference, all perplexity, that's all running. That's all using FP8 and acceleration. Yeah, everyone that's running stuff in production, no one's using PyTorch. They're all using TensorRT and VLLM, which still has TensorRT in it.
Yeah, I meant for training it.
Yeah. Again, for training, I am not sure about the earlier claim.
Yeah, did you see the NIMs? The basically like containers that can run AI applications.
Do you remember when you run NVIDIA SMI on the H100? What is this 450 watts, right? Or 500?
On a what? On H100?
Yeah.
I don't remember. Like,
Do
I
you have any
don't look at the wall.
screenshots of
I
NVIDIA
probably
SMI?
do somewhere, but like, yeah, just Google it, man. Like, it's pretty Googleable.
Yeah, dude, the NIMs were pretty random because, I mean, maybe I missed it, but where do they run? Or did they say you could run them anywhere?
No, you can run them on any NVIDIA thing. Basically, they're trying to create this like easier way to package your models and connect it to like all the different uh agent use cases. Really, like that's the thing, is that it kind of feels like they're capturing the a lot of the developments in AI with the agent frameworks and just trying to package them as a product. Well, that was interesting. Uh,
I just think RAG is way too over productized right now in corporate, and that's what
oh,
corporate's paying for.
they basically integrated into the NIMs. Yeah,
So a lot of this, just because it sounds like a big deal, doesn't mean it is. That's how corporate works.
But it just highlights the void, right? Like the the distance between innovation on the ground versus 90% of industry is still on chat with your PDF.
And people are still having hallucinations. But I don't think it should really matter what the heck NVIDIA does, or if you're using an AMD MI300 to your user experience. Yeah, we just need more. Like, we just need more.
Exactly. Like same chip, different chip, a little bit better this, a little bit better that. Like so much optimization is going to happen outside of NVIDIA. Like if they make a better chip, fantastic. But we could still do magic if we just get more of what is currently there. So
yeah, definitely. Again, super excited, man. Like we're really like seeing the start of something huge. It always feels like this with these new product releases. Like hopefully it'll feel the same when OpenAI releases their new models this week. Hopefully,
The reason I'm annoyed, I hope for 3 nanometer chips so that they can start driving down the costs of all these other things so that they can get cheaper. But no, they're just making the exact same crap and selling it for the exact same crappy price. And that is extremely annoying. They're holding back progress. I'm pretty sure they have 3 nanometer chips. They have a whole production
3
line of them.
nanometer isn't that much cheaper. It's probably approximately the same as 4 nanometer.
Well, 4 was more like 5, but for what we saw from Apple is that did make a a significant improvement. Like the TSMC 3 nanometer fab was completely different from the 5 and 4. 5 and 4 were the same.
Apple uses another 3 nanometer process than the rest of the industry.
That's true because they paid for the line, but we didn't really see a difference at 5 and 4 because it was just renamed. But again, it's not really 5 and 4. But we did see at 3 nanometers, we did see a very significant one, like the M3 Max versus the M2s had significant power differences, and that corresponded to that reduction. That's not the case here. They're still selling in New
I
York.
really wouldn't attribute that mostly to the chip design, especially if no, not the chips. I would attribute it to chip design and not to the manufacturing size, the node size, because you have a lot of other stuff that probably plays a much bigger role in the like half a node change between 4 and 3.
The way I'm seeing it is there's a GPU shortage and they're still just making H100s. That's all I'm seeing here. They're okay, they're great. You package them in a container, you put 1,000 gigawatts in someone's closet. That's amazing. They're still just making the same chip. It's still a bottleneck
What are you
here.
expecting? It's hardware. You can't just make it 10x faster between 1 year. You actually have to build something, and they would have needed to start designing it like 3 or 4 years ago. It's not that easy. It's hardware. It's not software.
Yeah, but every single other time, the V100, completely different chip die.
The V100 is many years old. It's like
Yeah,
probably
the
was designed 10
A100,
years ago.
the A100, completely new, different chip die. The H100, completely new, different chip die. 2 years after this, the exact same chip die.
Yeah, but like that means that they can produce it faster and it can reach customers faster, right? Like well, why is that bad? Even if they do have more innovations that they can release in the next few years.
No, they're producing the exact same chip.
Yeah,
Yeah,
listen, but
so what?
I
That
think
means that they
the
can scale
logical
it up, right? Like
the leap you're making here, that the same exact chip will not yield the same performance that they showed on stage, and I think that's a leap too far. I think for the panel here. Which you may be right, but it doesn't look like. And I'm just saying that a public company cannot just come out and say, "Hey, here's our performance that you're going to expect," because people are taking orders. There's a bunch of people there, enterprises, Dell, whatever. They're sitting there, they're looking at this, and it's like, "Okay, we're going to order." Probably the people who are making orders already ordered theirs, right? Everybody like Lambda and everybody has come out and said, "Hey, we're going to offer this chip anyway for we're going to be among the first." But people are taking orders based on those numbers. So those numbers seem, they have to be exact. It's a public company. So back
Uh,
to new chip doesn't mean like more performance.
yeah, it doesn't mean Google's demo is actually real or the FP4 matches the Float 16 drapes. Anyway, we have an actual chip uh, hardware engineer here too. Sup,
So,
Bubble Boy?
did you guys cover NIMS while I was away?
Hello.
Very
Hey,
briefly covered NIMS, very briefly.
I heard Pharrell, I think briefly is talking about this is kind of like a agent. That's what I was kept thinking about as well. Like this seems like very they're taking the direction where everybody's trying to go with agents and saying, "Hey, here's the architecture for this that runs regardless of which hardware you have." Something like this, right? Is that what I'm getting from the NIMS?
Yeah, but where I got lost is like, is it just another layer I need to worry about now? Like there was in the diagram, it showed like where Kubernetes lives, but is there going to be like NIMS hub, like like a kind of like a Docker hub kind of thing, or I just couldn't really understand where it lives, like the ecosystem around it.
Yeah. Just the name is like also important, right? The fact that he kept saying NIM for this, NIM for that. Naming is, as we've seen, very much important in this industry. But yeah, you're right. Like Kubernetes was like a layer in there. What are these names? The example he showed was them taking Llama 7DB or something, and then train it as a chatbot for chip design, and then it didn't give them the answers they expected. So they fine tuned it, and then the same name started answering better. So it's like a microservice, right? It's a microservice that exposes an API of some sort, but that runs on the probably you don't have to install like the different CUDA drivers, so like it's all pre-packaged and works
Yeah,
everywhere.
they're just basically building the infrastructure and standardizing it, which could be useful. Like I feel like that there might be a lot of uses for it for all of us if you want to deploy stuff to production. But like I don't know until I like get my hands on. What I think was under discussed and probably just the tip of the iceberg is um, how they're positioning themselves to be the layer for like future humanoid robotics. And I'm seeing announcements from all the or like most of the humanoid AI startups that are partnering with nVidia not only for the hardware but for their software and training stack. So like they're actually positioning themselves with the Groot project to basically be the operating system for all future humanoid robots and centralizing that um, through their platform, um, which is like this is huge on its own, and I think again something that's under discussed. And someone like Niston will say, but it's whatever. Okay, but like like it's Nvidia first off. They're like a trillion-dollar company, and by positioning themselves to do that, they're basically capturing the humanoid robot market, which will be in itself a trillion-dollar market, probably trillions of dollars.
Yeah, they have their own Docker too for a couple of years, and everyone still just uses Docker. Uh, NVIDIA has been also training their own models, and they've had their own model hub, and still everyone uses Hugging Face. So I think this is just all part of the course, just making consultancy type presentations to just get more corporate contracts. I don't think it really changes anything.
But dude, like corporate is where the money is. Like these huge companies, there's like Salesforce or Oracle or SAP or ServiceNow. Like they are gonna be paying so much money, like it's gonna be crazy. Like and then like yes, Hugging Face is gonna still be around, but if you're a shareholder of Nvidia and you want to see like a lot of chips purchased, this is a perfect play for them. Like it is actually pretty painful for a lot of companies to like spin up a a RAG type system, and to make it super simple, the adoption is going to be crazy.
That is literally what every GitHub repo of chat with PDF says.
Yeah, Farrell, like when you were saying the robotics thing, like he kind of reminded everyone that Jetson exists, right? I feel like no one, like Jetson just kind of fell off the face of the earth. And there was who's that guy's name? I forgot his name. The guy that made this truffle like LLM box thing.
Oh yes, Sim for Satoshi.
Yeah,
Same
yeah, yeah.
for
Like
Satoshi.
before he mentioned that, I was like, dude, I forgot Jetson even existed.
Yeah,
Yeah,
they're a
I mean,
repackaged 3090 with just slower DDR5, 64 gigs or 32 gigs of RAM.
yeah, I mean, like we're not in like personally, I'm not in like the robotics game, so I don't think about these things too much. So like I guess like I don't know, man. I feel like the they're re the fact that they're repositioning they're positioning themselves this year for that. They expect that most humanoid robots will use an NVIDIA GPU like that. Except possibly the Tesla robot that's going to use its own stack. But like most humanoid robots will be powered by some type of NVIDIA GPU, at least for now, until we see another player that has something meaningful. And I'm sure, like at some point, there's going to be rivals to NVIDIA with other chips, but they are a first mover in many ways, and they're going to capture a lot of the market. They're not going to die away anytime soon. And like Winston said, there's probably even more advanced chips that they're sitting on and researching and developing that will be released sooner. And like things like Grok, I think are interesting. But I mean, like, what's to stop NVIDIA from just like creating an inference only chip that um, performs really well for, let's say, a robotic use case, because you might not need like online training or continuous training for that type of system. If their vision is to basically have these like AI factories where you centralize all the computing and just like communicate back and forth with these like edge systems that like these robotic systems and like you saw, like they've even got at the end he showed this breakdown of multiple chips for multiple use cases, which all connect, and he has the DGX system um, for all the actual AI training and cloud inference, and then he's got the OGX for the Omniverse, so like the digital twin, which in itself is actually very useful for like these simulations are going to be very useful for training models and collecting data and generating data. And then he's got the AGX for like the actual like robotics edge systems. So if they take that even further, they could actually just build like much cheaper inference chips that could complete that stack and rival things like Grok and actually be even more
But why
useful.
haven't they?
But I think
Well,
the main problem
I don't know.
there is
Ask them.
production lines. Like you have to
Possibly,
actually
yeah.
build a production line for each and every chip, and that's hugely expensive. Like development is one part, but actually building a production line for uh, chip for only humanoid robots and another one for nuclear reactors and another one for XYZ is extremely expensive. That's exactly the problem with like electric cars right now, why Tesla is so highly valued
Why do they need to be separate production lines?
because they're
It's not a
different.
production line that the chips need to be designed, and ultimately the chip design is ludicrously expensive. Designing something like an H100 chip
Ding
costs
ding
hundreds of millions of dollars, at least, probably rather billions.
ding
And you can't make multiple chips without it costing
ding.
a lot of money. Additionally, for each chip you manufacture, and you need to test each chip, so you're usually trying to make the same chip, but cut down certain parts of it.
Yeah, what Felix said. They're like nVidia designs a core, and their core gets updated and iterated. They're not going to design a brand new chip. It just costs way too much money. And why would they do that when they already have like customer base and they have this whole software stack built around their
Well, they
product?
do that every like 4 or 5 years. They release a new stack, right? So, like,
Uh, but it's iterative. It's not brand new for inference. So I guess the question is
sure, yeah,
like,
but like if there is a market for that, why wouldn't they? You
um,
know, if there is if there is a market that will give them the ROI they need, then
sure,
why wouldn't they?
the inference market's bigger than the training market, but yet,
100%, yeah, and
but
at the
yet,
same time, you've got like if you're threatened by someone like Grok with superior inference hardware, or potentially another player who has just like superior inference hardware, then you would position yourself to actually capture that market as well. Especially if your whole positioning is that robots are going to rule, we're in the new industrial age, blah blah blah, right?
I
I
don't
don't
think
think they
NVIDIA
see.
is threatened by Grok at all.
yeah, I
Yeah,
don't
I
think
would
It's
say
so
the
fake.
either.
same
I,
because
yeah, go ahead, Julian.
I think the main problem here is for them is they can't get production up as high because we're literally talking about how fast like chip manufacturing machines, so the machines that manufacture the chips can be produced. So like it's literally like look at how badly that one fire was it a TSMC plant in Taiwan affected the whole chip market for years. That whole industry is so optimized that it's like they can't get production up high, and Grok is tiny in comparison to
Wait,
them.
a fire at TSMC delayed chip manufacturing for years?
I think it
That
was
was
Berlin.
21 or so, and then it took 2 years to get it back up again.
Yeah, but what timescales are we talking about? Because like now the entire capitalist machine is refocusing towards, chips, because we know that this is the future, right? So, like what timelines are we talking about here? If
Building a chip
nVidia
from
wants
scratch is
to,
like a 5-year minimum affair.
Yeah,
From starting from
and that
zero,
that
rather more.
doesn't, yeah, but
I would say
that
5 to
like,
10. Yeah.
wouldn't you argue that there is like a feedback loop here, like a flywheel, where
Yeah,
as we get
definitely.
better, yeah.
Definitely there's a huge industry of like, because the manufacturers of the machines, like the isn't it Texas Instruments who makes the machines to produce chips?
Oh,
ASML.
ASML.
Oh, yeah, that's the one. They are like they have to spool up production, but as soon as they get higher and higher, and now that everybody focuses, there was also this whole initiative with in US where they are bringing chip manufacturing back stateside. So
But
it's
then Zeiss too, because Zeiss creates the optics for the ASML machines. So they,
Sure.
It's a very,
uh,
very complex supply chain for the ASML
it,
machines. They're going
yeah,
to make as many as they can make. You can't really put them under pressure. There's incredibly complex supply chain that leads to making one of these ASML machines that they're now working on near aperture EUV lithography,
Mhm.
and that will come soon. But it's not that. So these machines are
Already
even
here.
more complex because the light source needs to be even more powerful. That's nothing you can really put them under pressure, and it's the one company that is able to make these kind of
Yeah.
machines.
what's really funny is
There's no flywheel effect there.
during the GTC presentation, I found it really funny that when they were presenting like the digital twin of the weather simulation, they're like, right now it's optimized for Taiwan, like because it's in their best interest to figure out what is the future weather going to be for Taiwan to measure out and schedule things.
I
I
think we
wanted
still have
to.
some flywheel effect here, though, because literally the governments are jumping on board because they see it as some kind of governmental homeland security part. Literally, look at, for instance, Germany, who
Mhm.
put a shit ton of money in that Intel comes to Germany. Look at Biden, who put a lot of money in that they move plants back to US. And one of their interests is literally that Taiwan is too close to China.
I'm
And
surprised they
The
don't
they
build
German chip
more.
factory will come in 5 years or something like that. It's no flywheel effect.
Yeah, I'm surprised they don't have more chip manufacturing in Netherlands because isn't that where ASML is based?
Yeah,
it would take for Germany to actually build a chip plant that would
Taiwan
take
is
normally
the
20 years.
Taiwan's a really good middle point because the labor is cheap.
Taiwan was just,
Sure, costs are part of it though.
yeah,
And
maybe a small part.
an engineer from there explained it that the reason it works so well in Taiwan and Japan partly is because he said that if you want a good job and you're on the island of Taiwan, you go to TSMC.
Well, there's
You don't.
another
There's no
organization.
flying to SF and raising a bunch of money and starting another failed startup. You just go to TSMC.
Yeah.
Otherwise, you won't make six figures.
No, I tweeted a joke. In Taiwan, you can either be a TSMC engineer or join the triads. There's no other option.
Yeah, TSMC is. I mean, there's like I think it was called Samsung Foundries before, but I think Samsung bought Global Foundries, I want to say, and I guess it's called Global Foundries now.
I think
But I mean,
IBM bought Global Foundries and then sold it off.
oh, interesting. Yeah, but there is, Intel has plans. Honestly, I don't. Intel has so much like cash and savings right now, from last I heard. Like, people say they're gonna go bankrupt and this and that, but I don't really think so. Like, I think it might take them a couple of years to kind of get things going, but I think they will actually be a competitor to TSMC to a degree.
Intel has first dibs on the high NA EUV machine, which is like the next generation. It actually just got shipped to them recently.
Yeah, I think they're one of the only competitors to TSMC in like the next 2-3 years or so. Because
On the leading
Intel,
edge, yes.
yeah,
I just wanted to add some color. So like we were all talking about like this investment, this huge push for semiconductor investment, and a lot of you were talking about how it's backed by governments, and a big reason is because governments need chips for defense, but these are not necessarily the leading edge, which is what's going to be your GPUs and your top of the line desktop chips and like server chips. These are like more mature nodes. So if you actually look at like the new fabs that are being built in America, they're like, memory fabs and like more mature processes, which do not need these advanced EUV machines. Just wanted to add that.
Yeah, it's also really interesting how, uh, just to put it in perspective, from a customer's point of view, the best, fastest inference API you can buy right now does not use any NVIDIA hardware at all. It uses a 60 nanometer chip made in somewhere Ohio.
Yeah.
The best training performance for
Grok is 32 nanometer. Grok is 32 nanometer, as far as I
oh,
know.
it's not 16. I thought it was 16. It's 32.
Oh, 32. 32 is really the biggest thing you can conveniently manufacture. It's like much easier to make 32 than anything smaller.
Yeah. So does anyone, I mean, maybe there's a controversial thing I'm about to say. Does anyone know if Grok actually has a chip?
yeah, they do. They do have a
Do
chip.
they really though?
Wait,
Yeah.
hold on, wait. So you're talking about Grok with a Q and not Grok with a K
Yeah,
like
with a
XA,
Q, with
right?
a Q.
Okay, yeah, they do have a chip. There's pictures of the chip. There's like,
I
yeah,
mean,
they
it
have a
could be
chip.
renderings. I'm not
No,
trying
no,
Yeah,
to
it's
it
real.
would.
I'm
They
not trying to
so
spread FUD, but
so they have the on Grok. They have like the C. It's either the CEO or the CTO is literally the creator of the TPU at Google. So I mean, it would be kind of.
I
It'd be.
disagree with that statement.
You
No,
disagree? Wait, okay. Is there maybe like
I've
go ahead?
seen.
So there's
Yeah,
this guy.
Jonathan Ross was on the TPU team, and he was like
He was on
credited
the
as one
team.
Here. I'll say
one of the
one of the
creators.
creators. One of the
Being
creators. Sorry,
okay, sure.
maybe it's
I
bad
just
to say
wanted to
the
clear it up
creator.
because there's a engineering fellow, I think his last name's Jacoby at Google, which runs the TPU team and is pretty like the guy who came up with that architecture.
Yeah, I should say one of the creators. Yeah,
Yeah,
sorry,
sorry. I just I
my
didn't
bad.
want to. Yeah.
But
But yeah, they have a chip.
yeah,
They posted videos of the chip. They have chip engineers working for Grok.
So why
Um,
is the memory 256 megabytes?
because they
210 megabytes.
because
210.
I mean the cost of memory is
It's SRAM.
It's SRAM, right?
You
It's
can't
on
put.
chip RAM.
Yeah, it's only SRAM.
Yeah.
You can't put that much SRAM on a chip.
but the interconnect. I
It's
think
limited.
the way they have like a big cost advantage because the first of all it's like on 32 nanometer or whatever you said, and then also they have that amount of memory per chip, but then they have it like things parallelized across, like 500, 1,000 chips or whatever. And like normally, if you were on something like 7 nanometer, obviously the amount of cost of all those chips like wouldn't really make sense downstream to the end customer. But since it's this node, they're able to like still have that many GPUs and still offer competitive pricing on par with like Together AI or whatever.
But honest,
Making small batches of non-standard chips is
Yeah,
really
and sorry, when I say
expensive. Like,
competitive pricing, I mean specifically competitive pricing like on per token costs.
but honestly, the main
yeah, I
use
don't think
for
it's subsidized. There's no way that they're competitive. If they had to pay, wouldn't have VC money, they subsidize it.
they have
Wait,
been
so you,
stealth
you
for a
think
long
like
while.
they're
So
so you think it's like actually like no way that they're actually competitive and they must be like in the negative?
What? Of
So
course.
they're
definitely
subsidizing it. They want
negative.
market share. They're getting great free promo. Like a lot of people don't understand what they're doing. That's not really that great of a business model. It doesn't scale. It has inherent limitations. You can't even put the current biggest models on such cards. It's not a great
Well,
business
not on
model.
a
Do you
single
know
card.
anyone
Right, well, not on a single chip, but
who
on
pays
multiple
for
chips you
Grok?
can.
Of course they are. Of course they're VC funded.
Yeah.
Who pays for Grok?
No, there is people that pay for Grok. Yeah, they
That's
have
not
an AP.
gonna. That's not gonna cover.
They have a paid inference API, and if you're just a
Yeah,
user, it's probably not even a bad deal. But it's not. It's a good deal because they put VC money in running it.
but you can't even fit like GPT-4 on a single H100, right?
You can on the
Yeah, but
TPU.
you don't need
Yes.
thousands of them for like, well, you probably would need 5 digits of clock cards for GPT-4.
I'll post the
That's probably would
TPU
run.
architecture. You guys should just read it because the 4,000 or so TPUs in Iraq, they can share the same architecture. The founder of Grok left when it was TPU v2.
Yeah.
This is all like well
Yeah, aren't
known.
the TPUs a
I
similar
don't think
style where the
why
TPUs are also like not that much memory per chip, but they're
They
able to
have
parallel?
102 megabytes of SRAM in
Yeah,
TPU.
exactly. Yeah, but then
They
it still makes
also
cost sense
Yeah.
overall because like people still decide to, they still decide
so
to inference and train on those because it makes cost sense.
Yeah.
TPUs have HBM memory. They are much more similar to a
They
GPU
have both.
than
They
Grok
have
cards.
both.
Yeah,
Yes, of course they have
They have
both.
both.
Every single
Right.
chip
Yeah.
has also SRAM.
But I just wanted to say the TPU architecture is this. If you guys want to look it up, it's called systolic arrays. That's really what the architecture is. TPU is just a name that put on it,
Yeah,
but it's
that's
like
right.
pretty well known.
That's right. Under the hood, yeah.
Yeah. And so
But
they're just
honestly,
like, yeah, go ahead.
for me, the main use for Grok is just showing higher ups that it's possible to be faster and they shouldn't worry about speed right now and look at quality. And shouldn't they, if my message appears like after 10 seconds, they shouldn't be like, oh, it took so long, but be like, oh, yeah, it's a good message. We should actually think about implementing AI somewhere. That's the main use for me right now because it's a way of convincing them that it's actually possible to get this shit fast.
it's indicative of the future for sure.
I'm pretty sure that it was either the CEO or CTO of Grok, like when they're first kind of going viral on X, there's some people saying things like, "Oh, there's no way that it's like sure it's fast, but there's no way it's actually cost effective or whatever because this and this." And then like either the CEO or CTO actually made like a whole thread going down all the costs and the cost breakdown of everything and what people are assuming wrong and how it actually makes cost sense at the end.
Mm-hmm.
Yeah, I mean it will at 32 nanometers for scale production.
Yeah,
It's
because
it's gonna
things
be
are
a lot
not
cheaper.
like a lot of operations are not like for inference is a lot of it is not operations per second bottlenecked in the first place. A lot of it is bandwidth bottlenecked. And so if you could have that really like high shared bandwidth across a bunch of chips, like it ends up being very effective if you can make each individual chip really cheap.
Consider that Grok, when you put one request against Grok, then basically 2 to 5 somewhere in the ballpark server racks are completely utilized only answering this one request for like 2 seconds or something.
Well, what do you mean like
And if you do the same on, they do nothing else. They answer one request for one person, and several server racks are only involved in doing that for one person, because they have batch size 1 and need a fuck ton of cards for answering one request.
here, I'll try and find that thread of him doing the cost breakdown, but I think a lot of the things you're bringing up are answered there. But I think like each one is pretty small too though. So I think like the amount that you could fit in like 2 or 5 racks or whatever, like I think
Probably 8 cards
I think the amount
for
of chips per rack is maybe more than you think.
So I think
Here.
No,
Felix is right probably in terms of power efficiency, even if they were 4 nanometer chips, just of how many interconnects there are, because most of the power is used on interconnects. At the end of the day, though, they're holding up. Their servers are not going down. You go there anytime. It's the fastest inference you can get. So there's that too.
But sometimes you're waiting a bit for the request to. It's not always the
Yeah,
thing is really. It's the
I definitely
timer is very
noticed that
late.
sometimes the latency, like you'll get the fastest inference once you get in the queue, but sometimes the latency is like 300 milliseconds, sometimes like 3 seconds. I've seen
Oh, it
this.
started queuing.
It probably queues.
that would
I have
actually
another answer for this. Yeah.
But that would actually be my main question about them is like, is that actually scalable? So if I would want to run something like
No, it's not.
the Klarna architecture, like what Klarna did with the what was it, 700 people replaced, would that be possible on Grok or would it just
Wait,
completely
when you say
crash?
Klarna architecture, like did they actually
Yeah, it's
replace
not
the
really an
model or?
architecture.
Oh,
No, it's
you
just
just kind of
A
meaning
shit ton
okay.
of GPT-4, I think, or GPT 3.5. But they made like
No, it
30
wouldn't be
million with
possible,
it, so
or at least extremely expensive. That it wouldn't make economic sense.
Yeah, that's right. I agree with Felix. Yeah.
So what about Cerebras? They have a fully PyTorch compatible stack. They released a 5 nanometer chip, and they're claiming, and it looks pretty legit. It's about like half the power to performance ratio of an H100 during training.
Is Cerebrus that company that makes the wafer scale chip?
That's right.
Yeah,
Yeah.
Interesting.
and they're all SRAM.
Yeah, I mean they're just doing what Grok's doing, except with chip
No, they're
interconnects.
not all SRAM. They have like a lot of SRAM, but they have HBM on the side.
Yeah,
Right.
so for Cerebrus, they have I want to say it's 44 gigabytes, 45 gigabytes of like on chip, like it's pretty much like cache, like it's
Yeah, that's
like on chip memory, and then
hmm
they have I think it supports like up to like 1.5 petabytes of external memory,
hmm
and it's like insane bandwidth, like way higher, or at least especially the on chip memory. Obviously, it's going to be way higher bandwidth than the HBM on NVIDIA cards.
I feel like that's just taking what Grok's doing and just scaling it to the entire wafer.
So Rebirth is optimized for, I mean, like they're not too different in operations overall, but Cerberus is targeting training, whereas Grok
Got it.
is targeting inference. Yeah.
Grok is really different from what Cerebras is doing.
Yeah.
It's really, really different. You can't compare it.
That's right.
It's at least not equated.
Yeah, Cerebus is designed so that you could like literally, like I mean, especially for smaller models, right? Like you could literally have the whole like chip, like or sorry, the whole architecture, like all on chip memory.
Cerebras, as far as I understand it, is much closer to like a really big GPU that you can basically like a CUDA GPU has like thousands of streaming processors that are CUDA cores that work on a task, and Cerebras does the same with much more cores.
Yeah.
And every core has their own SRAM, as far as I understand it, but it can pretty cheaply communicate with other cores. That's a bit different than CUDA cards because they have like certain restrictions how far they can communicate with other basically columns within the CUDA model.
hmm
But Grok is really, really different from that. They're basically running a predetermined script they're basically running a precompiled binary with a slightly different input each time.
Yeah.
What do you mean by
So,
precompiled binary?
They you need to schedule certain parts of the model to certain Grok cards, and they predetermine that. Whereas on CUDA,
Uh-huh.
you do that in real time. You decide on real time which core does what.
But from a hardware perspective, though, are they really that different from like what's the
Yes,
architecture
yeah, it's
of
very
the chip?
different. It's very different.
How so?
I think Cerebras is how big GPU can be. Um, it's more cores, which is relatively very different. Grok relies it just 250 SRAMs.
So, yeah, I'm getting the scale thing here, but like all I'm trying to say with this like incessant questioning of you guys is just like my desktop PC has 8 cores. A supercomputer has 256,000. Of course, they're kind of different, but in practice, they have the same architecture. Like it's the same idea.
Uh, well, I would say
no, they
depends.
don't have the same architecture. CPU cores are very different than GPU
Of
That's
cores,
right.
course, of
and
course.
those
I'm
are
making
very
an
different
analogy
from
between the two.
Grok.
So according to
Yeah,
the
but
website, Cerebras has 900,000 cores per like card. So I don't know.
Are those like SM core, like streaming multiprocessor cores?
no, that's one core.
Just
Like
one
then,
core standalone. Yeah.
those probably.
Okay,
I
interesting.
mean, it's 4 trillion transistors, and I think about 900,000 AI cores. So
Wait, back to the Grok thing again. Now that I think about it, the biggest weight on a Mistral or Mistral 7B is an MLP. Well, is the output that's 250 megs, but all the other ones are under 200 megs. So, Felix, are they scheduling it that way? So each one is per weight, per chip, per SRAM cache.
They can pretty cheaply communicate with other cards. They don't need to put each layer on one card. Does that answer the question?
Yeah, I just thought that the way you explained it, it would make more sense for.
But because they can schedule the cheap schedule, the cheap transfer between cards comes at a cost of being not flexible at all. That only works because you need to predetermine at compile time when which data bit, which packet needs to communicate, needs to be sent to one other grok card for the exact timing within their system timing model.
That's why they support only like a limited amount of like Llama and Mixtral and pretty much. Oh, and Gemini. They got
What's
like an
the
insane 900 tokens per second for Gemini, but I think that's right, Felix. Like that's why they're like limited and can't just put any model in there. They have to work.
There needs to be a limit on there's a limited amount of communication time on this communication bus they're
Yeah,
using,
just to
and
your point.
at some point you run out of
To
time
your point,
on the bus.
Felix. Also, too. That's why Grok is very deterministic. They measure every single latency within the.
Yeah, I mean it's basically deterministic in
Sorry.
this case means we're not flexible
Yeah,
at all.
100%.
Grok is not flexible at all. I wouldn't take
Yeah,
it that as a good
yeah.
thing.
On scaling, yeah. Don't bet on Grok for now.
So
That's true.
apparently they have it designed so that like one of Grok's advantages is apparently the fact that I guess the simplicity of the way that they design the cores and the architecture is such that like pretty much rewriting things at a very, very low level for that specific chip. Like a similar operation, I heard like an estimate of, it might take like a few NVIDIA employees, let's say a few months to like rewrite Llama at a very, very low level to be as optimized as possible for, let's say, H100 or something. Whereas for the Grok chip, they were able to like do the complete thing for Llama 70B within a few days of it coming out and have it already running at like hundreds of tokens per second on their chip. So that seems to be one of their big advantages is like the simplicity of the actual cores.
Yeah, it took them like 2 weeks for Gemini as well. When Gemini was Gemma.
When Gemma was open sourced, yeah.
Yeah,
Yeah, if you take like a 30,000 feet on this, what Grok is good at, I think, is they're able like to train very quickly, very rapidly, iterate over it, and you will see the kind of the same dimension on NVIDIA side is using USD, which is, I think that's pretty much where they're aiming at. They really don't care about hardware. They know where they are with the hardware, and they're trying to go to that USD part. Um, so it just everyone have accomplished it in its own area, and it just depends where you choose at. But all of them, they are coming cross in that sense.
all right, folks. So we've covered GTC a little bit. We've covered Grok. We've covered competitor hardware, which, by the way, a lot of it was released a week before GTC. Right? If Cerebrus was like released today, anybody would they even break the news cycle? I think maybe not. Um,
Did anything come out of GTC?
Yeah, so
Anything
they announced
important?
the B100 cards, I think it is. So that's like the successor to H100. I want to say it's at least
Is it
it's
better?
two it's 8 terabytes a second of bandwidth. I believe the H100 had around 3 and H200 had around 5.
Is the
So that's a big
memory
jump.
the same?
Memory is around 180 gigabytes per chip.
Gotcha.
It's
So that's
exact same memory chiplets and exact same die with some faster
Did they release
NVLink.
TDP for it or no?
so
1,000 watts, I think, for the
I think
that version.
it is like more TDP. I forgot exactly the amount. I think yeah, I heard rumors about 1,000 watts. And
What's a
like Vinicius
normal
said,
H100? Does anyone know off the top of their head?
less than 500 watts. I'm pretty
400 watt
sure.
for the PCIe thing.
200 watts?
400 watt for H100 PCIe and 400 for PCIe and 700 for SXM.
Okay.
SXM5, right?
Okay.
SXM is much faster and has much faster memory
And
and
H100
much
So,
higher power bit.
H100 has up to
Hello.
80 gigabytes that you can get it with of memory per
mhm.
chip, but H200 has
Hello, can
140
you guys play?
gigabytes. you can get it with.
I see.
I am here full.
Do we know any of the costs of the new card? So how much will they cost?
I'm not even sure if we ever got official MSRP for H200 or H100.
So it looks like you can just get one card instead of two. Am I wrong on this?
What do you mean?
Like you could just buy one card when before you had to buy two.
I'm pretty sure you
Wouldn't
could
that
buy
support?
one H100 before.
No, I mean, but like one card now, it seems like it has the memory bandwidth and the amount of memory as two.
Oh
Three.
yeah. Like if yeah.
Like you're saving some money. I'm hoping it's marginally less price than two
Yeah,
cards.
apparently the interconnect is like if you buy honestly I feel like they should have called it the BGX. I feel like they missed that, but
Or
they're calling it the
BBL.
DGX Blackwell. And if you buy the DGX Blackwells and take advantage of all that interconnect bandwidth for large training runs, apparently overall, like to train something like a 1.8 trillion parameter MOE model, it would take
Mhm.
1/4 the power as it would for if you were to do that with like H100s or H200s.
Do you guys know if it's still on the same process node as before?
Yeah, exact same. Hasn't changed. They're
Okay,
still
so
selling the same 2-year-old chip. Just
yeah, I mean it's a marginal improvement. Maybe you can cut costs.
I
You
think
just
we're
buy
with the
this
new
bigger
packaging.
chip. Yeah,
Well,
yeah.
compared to the H100, I would say it's double the memory and double the bandwidth. I think that's pretty big, yeah.
Right, but it costs more to cool and power these things than the price of the actual hardware.
True.
Like if you have this training for like months, I mean, and plus when they're in data centers, you need to keep them hot. As far as hot, I mean, like a hot dog stand, like you need to be selling.
Yeah, the amount of extra power it's using up though is only, like somebody else said, the SXM version of H100 was 700 watts. So 1000, it's only about 30% more power. That is a
He
lot
also
more.
talked about, LDJ, I don't know if you noticed or saw this. Jensen also talked about them shipping something like a test with every chip where actually don't know how to remember what he said there. He had like GPU security on chip, right? So end to end
Oh
Right,
yeah,
for
if you
enclave.
buy
data
at
protection.
least,
Yeah, it's
yeah, they
enclave.
Yeah.
said,
Yeah.
yeah, they said if you buy at least 5 of the GPUs, then they'll give you at least 2 security guards for free. Yeah. I'm kidding. I'm messing around.
No,
But
this
yeah, I
this,
know what you
this
mean.
sounds like like when you go to the Gucci store and you just waste bad money. They're like, "Hey, here's a free T-shirt."
Wait, no, security. I don't think it's bullshit. Security is very important now, especially because like
Nah, I'm not
even
saying it's
Mark
bullshit,
Andreessen talked about every lab is penetrated with like a Chinese spy or something that steals the weights.
bro.
dude,
Have you guys
Jens.
ever been in a data center, like in like a real one?
Yeah, it's not that
The
easy to really like
oxygen will get cut out,
it
bro.
yeah, it's not easy to like steal like a lot of them
You
like
can't
I
get
mean
on
I don't want to
site,
say
man.
too much because there's probably like certain
These
details that
places are
are
like bomb shelters.
like okay, here's like an idea of it, Alex. Like I know of certain places that the USB sticks, literally if you try to walk out with one of them, the USB sticks themselves are connected to Wi-Fi, and if it detects that it's left a certain vicinity, it literally wipes itself.
But haven't you seen Tom Cruise? He'll hold his breath for the whole duration.
True.
I
Like
think
Tom
they're
Cruise.
Tom Cruise.
Don't let Tom Cruise close to the OpenAI headquarters. Yeah.
Yo, I'm just saying, like data center security is insane. I feel like it's like close, or if not just as good as like nuclear power
I mean,
plants.
there's a reason why you don't hear that many leaks.
No,
Like you hear
like
some, but
they're literally bomb-proof walls, like
Yeah, but like if
earthquake-proof.
one engineer sits in like OpenAI and starts like trickling a
Well,
process
that's
of like
open AI. That's not the data center.
yeah,
I get
but
what
I'm
you're
saying like
saying.
if in the context of them shipping some new stuff with their GPUs, the encryption at rest, but also during training, where the data kind of lives between chips. I think that's also an enhancement that they just announced.
yeah,
Sounds
true. Yeah,
cool.
that's the more you could improve security is always good. Yeah.
Yeah, even
One correction to earlier, I looked it up on the website. Grok on the website says 14 nanometer process, so it's not. I was wrong. With 32 and 14 is the
Oh,
correct
I
number.
thought 60. Okay.
Oh, so apparently the B100
Move
is
button.
actually the same TDP as the H100. It's the B200 that has more TDP than the H100.
I've
right.
been telling you guys this for like 2 hours.
Oh, sorry, I didn't hear you say that it has the same TDP.
No, he's
Yeah, but
just saying
also,
it's the
Nistan,
same
you also
chip.
didn't watch the keynote, so
I
you know.
didn't watch it either. I just come on Twitter Spaces to figure out what's important.
Dude, I'm not watching a religious experience that looks like another that
But no
It looked like a
announcement.
parliament.
Taylor Swift concert.
No
Wait, why wouldn't
announcement.
you watch a religious experience?
No announcement of inference first chip. So I mean, maybe next year.
But they did talk about inference as a category of things that were overlooked so far. And
Yeah,
on the
Yeah,
inference graphs,
they're overlooking it for sure.
no, but like on the inference graphs, they showed a significant improvement in like, yeah, Nissan will say like they skewed this graph with FP4, right? But like they're showing a 30x improvement in inference for these next cards compared to previous ones.
Yeah, I think
Interesting. I mean,
there's for the inference, I think they touch on it, but just slightly. It's like the Tensor RT, which is like it's got it's like the operator, like you can think of it like in the name service itself, and it's just pretty much pulls up all the NVIDIA RAG LLM altogether. So you can think of it
Yeah,
like Kubernetes, a Kubernetes operator.
they cooked that graph so hard. FP4
I
this.
didn't even know
Like,
FP4 was a thing.
Sure.
It's like floating point, 4 bits, or or is it something else?
yeah,
I
yeah, it's
think this
4
could
bit.
actually be used more for training. Yeah, I think like, well, obviously for inference, that's pretty important for inference
Four
actually.
bits? Come on.
Wait, a lot of yeah, a lot of people use 4-bit for inference, and it's like the preferred like
No, I get
trade-off.
it, but floating 4 bits.
Isn't that like 16 numbers?
I'm wrong.
I mean, but we
That's
saw
for
like
int4. No, I'm wrong.
so okay,
Back
I
to
think when you
back
allow
to
these new
computer science one.
capabilities, like when you have the new processor that has these capabilities, I think a lot of times you will see research papers and people like figure out ways where they could actually take advantage of that. And like for example, we saw the Microsoft 1.5-bit paper. They probably would have come out with that even sooner if you had a chip doing specifically those kind of, like low precision operations. And so I think they will probably come up with inference method and training methods to take advantage of FP4 since it offers huge advantages.
Yeah, maybe I just gotta look this up on my own time instead of being taught by the people in the space. But I just can't see how you can have 4 bits represent a floating point number. One of the bit needs to be the sign. So like, how many's left?
All of
Well,
them.
3 bits. Like, what range are you
They're
really getting?
I don't think they're signed because half are the mantissa and half because they say there's 3 and 1 where the
Okay,
first yeah like one's the exponent, once the mantissa. So you
so
gotta have
it's some jazzy floating point. Okay, I got you.
yeah
Yeah, have you seen
yeah.
the Microsoft 1.5 bits paper?
I did see it. Yeah.
That's not
Yeah,
also 1.5 bit. Like they left the last weight at F16 and
I
it's
think
all
on
two
average
bits.
overall, I think when I calculated the average overall, it ends up being like average 3.5 bits or something like that, something around there
Yeah,
for
and
the whole
you
system.
can do that now with the Llama CPP in mixed 2K.
You can do.
Uh, that
Oh,
also leaves the last weight.
interesting.
Did they announce any who is going to be the first company to adopt these new chips? Is it Microsoft?
They released a list of testimonials by the top companies. I think Alex posted that. But like, yeah, like OpenAI, Microsoft, Google, blah blah blah.
Well, I think
The fat cats.
I don't know. They said something about Microsoft, but then Microsoft in their last event literally mentioned that they're developing their own custom chip now. So I
Yeah,
don't know.
but
Microsoft.
not
It's a funny
mutually
situation.
exclusive, right? Like,
Have you guys ever heard of Project Catapult? Microsoft's been doing this for quite a while for accelerating Bing search. They have their own hardware for that.
I did not hear or know about that, but I know
So
that.
someone at Grok actually worked on Project Catapult. Um, Fun fact.
Did you know that
Interesting.
Microsoft has the fastest Bing search in the world?
That's why they invested in hardware for this Bing acceleration.
No, I think the joke is that Microsoft is the only one doing Bing search, therefore they're of course going to be the fastest.
No, I mean
Did you know
that
that?
Yeah.
their
Did you know
search is
that
pretty
Bing is
fast.
actually profitable? Bing actually makes money, in contrary to like
Yeah, they actually have a
a lot
pretty
of
good
other
ads
startups.
platform. Yeah.
And a lot of people are unable to switch
Yeah,
because they get it with every
Well,
new
because a lot of the
Windows
elderly
update.
people, as soon as they get the new computer, it's already pre-installed with Microsoft Edge that automatically takes them to Bing. So it's like,
listen, I don't
you
think
know,
Bing's that bad, honestly, but look up Project Catapult if you guys are interested.
Yeah, I think they're far way behind, to be honest. They still like around FPGA for Microsoft.
Yeah,
And they're using
'cause-
NPU. It's not even like so. It's very different architecture. Like from a software point of view, they have to build up like a whole lot of kernels just around it.
wait, are you talking about their like
Project
the new chip?
Catapult's
Catapult.
No, because
not
I'm talking about new chips that they're making called they're called Maya chips or Maya and Cobalt, which it's like their new AI specific accelerators for I guess they want to use it for OpenAI and things like that. Because remember, like part of OpenAI's deal with Microsoft is providing like compute for training and stuff. So yeah, apparently they're developing custom AI chips for that.
So
come on.
who's the top who's the top contender against nVidia?
I know if Intel keeps letting me down with
Probably
GPUs, but
Yeah.
Intel could like depending on what they do and if they make the right moves, like they not only have a bunch of like R&D
ask
for general
yourself
chip making, but they actually do the actual fabrication of the chips too, like as soon as they get the
or
new ASML machines. So
ask
like
yourself who has $50 million burning a hole in their pocket.
Million or billion?
Million
who?
to
That
a
Billion is
sounds
hundred.
nothing.
very low, very low.
Very few people have 50 to 100 million just being like, oh yeah, we can throw this at a completely new product line. And we don't even have customers yet. Like we don't even have
But
Yeah,
like
no, no. There's
distribution.
people that have 50 to there's like when we're talking about the chip race at this moment, it's mostly dominated by you know like like bankrolled by governments at this point, right? Like there's a lot of money that's just going into chips.
to be
So
honest,
like
but
if a government that's pretty well organized, for instance, that wants to invest in and that has a lot of money and that wants to invest into a new chip or chip fabs or whatever, they
They
could.
could invest in fabs, but are they really making the new compute architecture of the future? They're
Well,
gonna topple
they
Nvidia.
if you've got 100 mil and you can throw it at.
Using it effectively. I mean, governments have tons of money.
I mean, don't forget there's ARM in the market as well. They're not as bad as people make out. So
Again, though, like the thing is, it's like once you have a money machine and play the theme song, it's so hard to like invest money in making a new money machine. Like it's a huge risk.
Yeah, for sure. But if you don't disrupt yourself, right, like someone else
For
were,
sure,
I
but like
mean,
chip
like
companies are
you think
very.
Jensen? One second, sorry. You think
Yeah, go
Jensen
ahead.
is not aware of like the potential of thermodynamic chips? Like, I'm
Uh,
sure he is, right? And I'm sure they're spending R&D into it.
yeah, I mean, shout out Beth. Um, yeah, I'm sure he's sitting around thinking like, who's gonna take market share from me for sure.
did they
that's
announce it?
honestly the main problem right now because nobody's actually in actual competition with them. So they don't have to, like as many of you said, they probably have a like better chip right now, which they're not releasing because there's no competition. Why should they? So that's the main problem. If there would be competition from AMD or ARM, then they would have to release it to keep their market share, but they don't.
Yeah, and to your point earlier that yeah, like this is hardware, and especially in this industry, it's moving at the speed of the thousands of people of like stakeholders in the supply chain, right? Like there's a lot of like bottlenecks there. Um,
Sure.
so
I
like that's why um, for someone to win at this point, like to me, Nvidia has kind of got the
a
like full
monopoly.
advantage, right? First mover advantage here, right? But like if anyone else wants to win, they're gonna have to invest into another path up the tech tree, right? And like that's at least that's the only way to kind of avoid all the bottlenecks of the supply chain is to create something that doesn't require thousands of stakeholders to actually like create, right? And doesn't require these very expensive billion-dollar machines to actually manufacture.
I
Nvidia,
agree.
You can't make a chip just simpler,
yeah.
making that there is a very high complexity, a reducible complexity in making bleeding edge chips.
Yeah, I was just about to say Nvidia is relying on the same complex supply chain as their competitors and everyone else. Um, yeah.
Well, not
Like
I
necessarily. I
think
mean, Intel has the supply chain advantage in terms of they'll have their own, like, they'll be fabricating in-house instead of having to outsource to TSMC.
sure, but they all are buying the machines from the same people.
Yeah, they're at least supply constrained by ASML, yeah.
I think the only exception that would be possible would be like actual money. So not 50 million, but 50 billion or 500 billion. But at that point, we're only talking about like the ultra big players. So Apple maybe or Google or some of them.
I
Yeah,
will just
But
also,
say,
out,
look, if someone
outside of
comes
that,
around with like a great chip and it's a lot simpler and uses less power just for inference, right? And they go to TSMC and they say, "Hey, I want fab capacity." Like TSMC is not saying no if you can foot the bill. Like I don't
yeah, but
think like
they've got an upper cap to their capacity, right? To their production capacity. So
for
like
sure.
if you're playing also like it's not enough. Like yeah, sure, Intel can compete or whatever, right? But it's not enough to have like capacity to actually produce your chips. But it's also like the reason in like Intel or whatever isn't being used as well is because of the software stack and like CUDA and NVIDIA's entire like software stack is very well developed and very useful.
Yeah, that's
Uh,
their biggest moat for sure, is
so,
software.
It's
so like if you so you don't even like if you're competing on the same kind of uh like tech, right?
Hmm.
And you don't have much differentiation there. Um, you're not gonna really be able to get any market share over Nvidia because they do have that first mover advantage. They have all these relationships with the supply chain, and
So I
so,
think
so it's gonna be hard for new players unless we have more chip manufacturing capacity, which will happen over the next 5 to 10 years. But until then, the only other like competition that I see coming out of like against Nvidia is just another path up the tech tree. But that won't like happen for again another 5 to 10 years.
so.
I
I
think on
just
a
sorry. Let me just say a quick point, and then I'll give it to you, and
go
we'll
ahead.
stop arguing. I would just say, yeah, the software stack is definitely a moat, but I feel like Google TPUs seem to work pretty well. They're more power efficient. I don't know how they figured it out to integrate pretty well. So I don't think it's impossible. I don't think it's as big of a challenge as everyone makes it out to seem.
So first of all, on the software stack part, wasn't there one guy on Twitter who was constantly ranting about the AMD architecture? Who was that? Who was trying to get them to open source it
Georgie.
because it was, yeah, that was so funny.
Tiny Corp has Tiny Corp is the name of the account.
That was so funny. But on the how to beat NVIDIA, I think there are only two ways: either a fully new architecture in terms of hardware, like something we haven't seen yet, and on the other hand, is more efficient algorithms. So if you don't need 100 H100s, then because you have better model, better architecture, something else, then you can implement that and get around NVIDIA just because you don't need them. but I think that's the only two options. Actually, beating them on a scale is impossible.
I think one of the problem of AMD is the porting. Is every training that they do in Windows, it stays with Windows. They can't cross-platform it. Now they're trying to solve
It's
that with RAM. It's called RAM. They're trying to solve that, but I think that's where the bottleneck from a software side.
it's pretty hilarious to me how close to like $1 trillion or something in market share depends on freaking George Hotz fixing the AMD drivers. Like that is just bonkers because if you can get them to work across the network, then it's fine. I mean, Facebook has shown that you don't really even need NVLink. They just did it all over Ethernet. Those protocols actually work pretty well. If you have like 200
X.
Gbps or like 400 Gbps, you can get most of the performance. You're not going to lose all that much from not
X.
having 600 plus 600
X.
gigabit plus
Yeah.
NVLink. So
The
it's
Ethernet,
hilarious. Like it's
Ethernet and
just
HPC is like always the answer. Like everything's on Ethernet anyway. So
If the AMD drivers happen to work really well tomorrow, there would be a huge shortage of AMD cards. That much market cap isn't dependent on that. They couldn't manufacture that many cards anyway.
Felix is thinking like a fucking 200 IQ hedge funder right here.
Yeah, there is a very interesting part in today, Jensen, like GTC point. I think one of them is he's comparing what is the largest transistor available now. It was Cerebras. It was about 256 exaflop, and I think the Blackwell it does it about, I think that's like 1,000 of it at about 2,000, like 46 of nodes. So the scale is too big between even Cerebras and NVIDIA itself.
It was nice talking to you
I
guys.
didn't get what you're saying.
Bye.
So it's like in terms of exaflops, for Cerebras, you will need about 2,048 of nodes to match 256 exaflops of compute power.
Okay, but who thinks like that?
Jensen, he's just like
You're not
basically he put it like
starting
zero
with
point 0.1
wanting.
today.
Yeah, but that's like because Jensen wants to say something
That's
that
right.
makes him look good, not because you actually need that amount of exaflops to get anything done. You can get things done with
Yeah, that's right. That's right.
other
I
constraints.
mean, the other thing they introduced today is called the QOP. It's basically it's the very same thing what Grok is done with the ops. With hops, they have hops, so the very same. So it's just like it feels like Nvidia today is tapping to all of all of Battlefronts, but without introducing any new hardware. It's just iterative approach.
I think like an area that people can actually compete with NVIDIA in, and I guess it's technically indirect competition, is by targeting things like consumer price GPUs, because NVIDIA obviously has shown, at least according to the leaks of their next gen consumer cards, like they don't care about raising VRAM really. Like which is honestly the biggest bottleneck in terms of local inference right now of like what people actually want to do and can do. And so like as soon as somebody can have like that covered and then the software part covered as well, like AMD is kind of already halfway there. Like they have consumer GPUs that already have like support significantly amounts of higher like amounts of memory at consumer prices. Just they need to get the software figured out so people could actually use it on their own computers. But a company that does actually have it even more figured out than AMD is Apple at this point, because you can actually get a consumer laptop that costs like less than 5K, that has like over 64 gigabytes of high bandwidth memory, like or even like over 100 gigabytes of high bandwidth memory, and you can run things locally, and it's even actually easier to train than if you're using an AMD GPU. And they already have the whole MLX training framework and inference framework, and a bunch of software already supports it. And it's like they're kind of already ahead on the local front.
You shouldn't call normal memory high bandwidth memory, because high bandwidth memory is something very
Oh,
specific
sorry,
for
yeah,
certain
you're
piece of
right. I'm not
hardware.
talking about HBM. Yeah, you're right. But it's also
Yeah, I
it's
totally
also
got
not
it, but
memory though. Well, it's not like regular memory in like a motherboard, because even if you put DDR5 in like a standard motherboard, you're capped at around like 100 gigabytes a second bandwidth max. But with unified memory with like the M2 Ultra, you can get up to like 800 gigabytes a second, which is that's similar bandwidth to 4090.
it's still like half of the 4090 or something. It
A
still works.
4090 is only about 900 gigabytes a second.
Oh,
Yeah.
really? Oh, okay.
So it's like 20% less than 4090 bandwidth.
Yeah, it has way more cache though. That's what 70 megs or 70,
You're saying the
76.
Apple chip or Nvidia chip has more cache?
The 4090.
Oh.
The Apple M2 and M3 GPUs are pretty bad on cache. Like they're pretty slow.
From what I saw, like I guess like the cache doesn't seem to matter too much, at least in the inference I saw, because there was
No,
I want so I want to say it's
logical.
about like I want to say the bandwidth is about 84% the speed of 4090, so like not accounting for cache. But Georgy Gerganov, he has an M2 Ultra where somebody was trying to run, I want to say, I forgot what model it was, but some small local model, they were running it on a 4090. So it was actually Technium posted it. He ran it at something like 15, 16 tokens a second or something on the 4090. And then Georgy Gerganov was like, "Oh, look what the M2 Ultra could do, though." And it was running like the same Llama CPP, like same software pretty much, but it was like at 85% the same speed as the 4090. It was like the percentage of same speed that it had in tokens per second was almost exactly matching the percentage of bandwidth that the M2 Ultra has relative to the 4090.
But that's definitely
The
what.
problem is really that batch size 1 is really a really special case in
Well, if
most
you're doing local inference
hardware
like I'm talking
configurations.
about, then you're
Yes, of
yeah,
course.
you're pretty much only wanting you're usually only doing batch
Yeah,
size one at local inference, yeah.
but NVIDIA isn't optimizing for
Mhm.
batch size 1 usually, so that's the reason.
Yeah.
That's definitely what's going to be in the next like M4. Like I bet there's going to be a local model running on each and one of them, and then they're going to have like a big thing about it's local, it's secure, and the special part and all of that. You'll have it very well integrated. That's the Apple
Yeah.
way.
I mean, I think Apple's perfectly positioned for that because they control the whole operating system, the whole hardware stack, even down to like, the CPU and GPU and the motherboard. And then they also do the whole chip of the AI part as well. So it's like, apparently with the next iOS or Mac OS update, like announced this year, they're apparently going to have a shit ton of like local processing for AI.
And they
Like
even
as a
control
model.
the software.
Yeah,
Yeah,
I
So
they
you
think
can
they're
can have
even
gearing up the MLX. Yeah, all the
Yeah, they
MLX.
can even control like the exact neural networks being used for different applications and like the operating system features. Yeah.
So I
You know,
bet you have like a co-pilot level of integration with like everything on a Mac. So everything from Safari to what is the slideshow version on Mac? I don't use it.
I don't know. Did you guys see the
Keynote.
Gemini news?
Yeah, so what do they need Google for? That's where I got like today's
Okay, I
post
saw
was
that
super
too.
confusing.
because they
I think
suck. That's why
I,
they need
no,
someone else to
I
do
think
it.
no, I think that might be specific to. Well, I mean, first of all, like things could always be rumors and misconstrued and stuff, so it could be part of that. But at the end of the day, I mean, search, right? Like Safari search, like if they had some partnership where you get like free Gemini access for everything you search, like on the actual internet, I mean, you know, then that could work out. And then for everything that doesn't require internet, then it could run locally.
They've
Because
had
I
like
mean,
a semi transformer running Siri's voice recognition for like 4 or 5 years. Whisper's been out for 2 years. Siri is still dog shit. So that tells me that there just is a skill issue at Apple.
No, because they
it's
haven't
not a
even
skill
attempted
issue.
to
Listen,
update it.
did you see the MM1 paper they just released?
Yeah,
It's definitely
exactly.
not a
Like
skill
it's.
issue. It could be a scale issue. It could be just literally Apple may not have enough compute, like GPU wise.
I mean, I think it's everybody. Like, I know people that works at Apple and then currently work at Apple, and like pretty much everybody agrees it's just like a bureaucracy issue, really. Like, it's like everybody, like they have the talent, they know that they could push out better Siri this or Siri that, but at a certain point, they're like, whatever bureaucracy is preventing it from switching too much to neural networks or too much to the state of the art because they think it's maybe too risky. But then at this point, it's been so long that now they're just like, okay, let's just not touch it. Let's just work with our heads down on like complete next gen stuff from scratch. And then when we have that polished and everything, then we'll make a big announcement fully replacing Siri with all this, way better state of the art AI stuff. So I think that's what they're working on now. And I think they'll have that announcement either at iOS 18 launch for this year or like sometime within the next like 18 months or something. That's what it sounds like to
I
me.
think I agree with you because they have the huge advantage that they're Apple because they have the whole ecosystem, and everybody expects from Apple like a ultra polished, shiny thing, and then you'll have like the fancy presentation in Apple Park and all of that. And I think they are just gonna polish it all the way and get away of like the scared. They think they're scared of what happened to Google when they released the not so good models and their stock price tanked
You think they're
like
scared,
in a
but they're
day.
still like offering a partnership with Gemini?
Yeah, but
With
see,
But
Gemini?
they
like,
had dinner, or is that Tim Cook
That was an old
and
picture. Yeah,
is that old or is that fake?
I saw a caption that said it was like from 2018. I thought.
you know what it might be? Because I'm pretty sure, if I remember right, Google is in an official like licensing deal or partnership thing with Apple, where they're apparently like they pay Apple like millions or like dozens or hundreds of millions like every year
Billions,
just so that Google is the
billions.
default search engine on Safari.
Like
And
8 billion or something.
yeah, I'm trying to make sure I'm not saying too high of a number, but yeah, it might be in the billions too. Yeah. Um, but yeah, so like the fact that they have that deal, like imagine that they're actually renegotiating with Google to like, to either let's say to take away to take away Google search engine or Google's like, hey, since you guys already have us as the default search engine, can you like have Gemini support in there too? But like either way, whatever discussion they're having, the reports are going to come out the same that oh, Apple is in discussions with Google about something search engine related, right? Like
Can I?
For what it's worth, it would be a huge win for Google to get this though, because like on the whole, it's like a TPU success story, right?
yeah,
You-
imagine the deal is like, hey, let us have Gemini as a default on Safari search, and then we'll if you do this, we'll give you access to a bunch of TPU clusters for training. Like something like that, that would be funny.
And it'll be finally a win for Google because they like really been using against Microsoft.
I think to add a little bit context here, the Bloomberg article. I'm not sure if you dig into it a little bit more. There is a similar talks like has been held with Microsoft, like OpenAI, essentially even before than that, just a few days, not that
Mm,
far away.
yeah, okay. I might as well read this out for people too.
That's
So
right.
here's the main points of the article. Yeah, so it says Apple is in talks to let Google Gemini power iPhone AI features. Here's the first bullet point. Companies considering AI deal that would build on Search Pact. Search Pact is probably referencing, Google paying billions every year to have be the default. Then it says Apple also recently held discussions with OpenAI about deal.
That's right. That's right.
Um, yeah,
and
interesting.
and I think the integration part, it was not really like most of people assume that it's around like Siri and stuff like that. It's more or less about AI services like from Google Cloud, because it's very known that the majority of the clouds that Apple has, it's not Amazon. Majority of it is Google. So that probably is just about wrapping up their buying of more like AI and that sense chips and that sense from Google as a cloud service. That's all. Don't think
What
it's
I
around
don't get is
Siri.
why I don't get why they even have the need to get a model from Google because like imagine
I
how
think
big they
not the
are and
model.
if you look
Maybe
at their cash statements,
to refine
if
that
you
a
look at
little
how
bit.
much cash they have,
Sure, sure. But I don't
look
think it's the
like
model that is more important. It's more important is basically the cloud services, because they run a lot of cloud infrastructure with Google, um, and it dated back about 8 years ago. So basically, Apple switched it from away from Amazon almost like rapidly buying all the cloud, like with a bigger gigantic contract for 5 years plus. So this, I think, is just strategically that they just want to basically, settle the allocation for them more than less. But I don't think it's around Siri or anything like that, because Siri, I mean, majority of any ship now or anything, Siri is just a small, like, audio, text to audio, probably. It's not that big of a deal.
There's two other advantages that come to mind. One, it's like if it sucks, you always have someone to blame, right? Like remember, like any issues with maps, they could blame Google until they released Apple Maps, and then they realized they have no one else to blame. But and then also like I feel like Apple always loves to have someone that they can squeeze and just like juice down in future deals. So even though this would be like putting Google services in everyone's phones, it's like you kind of have your thumb on Google from that day forward to down the line. So I don't know. This Apple plays interesting games.
Yeah.
For me,
If you
the
following, sorry.
like the main point was that they had cash over years. If you looked at their cash statement, they've been hoarding cash, especially overseas, because they do this tax trick where they never get it back, especially in Ireland. So they have a shit ton of cash there, and everybody was expecting them to just pour it at the new investment. I would have expected them to like pour billions and billions into this and then just come out the gates storming and
Yeah,
just
we
be
also
like, yeah,
thought
we
they'd
have a
make a
new
freaking
model.
car, but that didn't, that didn't happen
Well,
either.
they
Yeah, they
were
canceled that
yeah,
shit.
they were making the card, to be fair, though, at least from what the reliable sources say, according to anonymous sources. But but I think like one of my theories is Apple did actually have first dibs. I want to say it was either 4 nanometer or 3 nanometer from TSMC. Apple had like dibs on like the entire first year supply of
On the
that
three,
production,
yeah.
and like they had the first dibs on the entire first year supply of that, and then they ended up like there's a lot of supply chain analysts that I was following and stuff talking about how they seemed like kind of overstocked on M2 chips and things like that. And then but then it was kind of weird because then around the same time the MacBook Pros and MacBooks started kind of going out of stock, and like it didn't seem to follow. But then I when they started working on MLX and things like that, then I feel like it makes sense that they might have just used a bunch of their M2 chip supply that they ended up getting to build out huge like server like capacity like internally with their M2 chips. Because remember, they already have Mac Pro server racks that they do already make. So they already have a production line for server racks. So and
So
they
you
already
think
have MLX framework too. So I think they probably developed MLX and developed their own in-house training system with like just a ton of compute. Yeah.
we think they have like a huge rack of just MacBook Airs plugged into each other
Well, no, not
below
MacBook
Apple
Airs.
Park.
They already have a production line for server racks with M2 chips
No,
in
just kidding. Just
it.
like I was imagining
Yeah.
the
Okay.
like stacks of MacBooks just below Apple Park,
Yeah.
just like
Yeah, they're probably
all
still
connected
using
by their one
Apache
USB-C port.
Mesos, something
Yeah.
like that, some
I mean,
crazy stuff.
theoretically, I mean, these would be pretty like power efficient too. Like these would be power efficient servers because not only is like they have a good amount of memory you can get in each server rack, and then the max, I think it caps out at like 60 watts or something. Like it's like 10 times less TDP than like even like a single H100. So I think the economics works out, and that's probably where a bunch of that extra supply of M2 chips went.
Yeah, I think if you dig in the MLX, I think it's very. I mean, how they are gearing up is just toward the transformer, like the text generation, generating the images with stable diffusion, and the speech recognition, similar like OpenAI, the Whisper. So they're not gearing up so much, and even though Apple, it's never done something that is very outlandish. They're always very precise. So I'd say a little bit anecdotes for it.
I think it's becoming pretty obvious that this stuff is hard and your evaluation does not there's no correlation between valuation and making a nice product anymore.
True.
Like that's becoming pretty it's hard to find the right humans to
I
hire.
mean,
So
nVidia is like like $2 trillion right now, or 1 trillion. I forgot what their market cap is now, but like
Yeah, is
Yeah.
Megatron any good?
Yeah, I mean, I don't know. I consider a lot of that stuff like to be very much like research things. Like even like Ferret, remember Apple had the open source project they released called Ferret. I think a lot of that is just like honestly maybe even like no offense to the creators of it, but it's maybe even interns like creating a lot of that. Then Apple's like, oh yeah, like open source that. And it's like a lot of it is probably just for recruitment purposes, just like how a lot of other companies like. I mean, it's obviously a good strategy, like just releasing anything open source, really, as long as it's like decent and related to that field. Like that does attract recruits. That does like incentivize people. Like, hey, look, if you come work for Apple, look, there's a chance that you could also flex about your stuff to others by making it open source instead of just having to keep it secret from your friends.
Yeah, I think Apple is like they itching their head. They're thinking like, how can we sell these? Well, it's Nvidia, they're trying. They already have, I think, the big players. They're trying to sell it like a hardware, full like data center. Yeah, Apple, they're probably thinking about how to actually. I mean, they do have already like the metal in place. They do have the unified memory already. It's doing pretty much good already. So it's just more they're trying to like connecting the dots, I guess.
Yeah, I think a lot of people. Have you heard of RWKV or any of you? Well, I know Niston,
Mm.
you definitely have, but
Yes,
Yeah.
and I'm so excited about it because I wrote my bachelor thesis about RNNs, and I'm actually excited about that
so the
happening.
reason I bring up RWKV and ask if you've heard of it, because the original RWKV, like that whole like origin story, it's originally inspired actually from an Apple paper called Attention Free Transformers. And that was a paper Apple put out back in like 2020 or 2021. And then RWKV like started out as just an attempt to try and replicate that and evolve from there. And like they definitely do have a track record when people look closely of like Apple has some good AI research and AI engineers really doing stuff.
Yeah, that's what Siri, I think, Siri's model runs on too. Is that strange transformer?
I think maybe for the voice aspect, but
Yeah,
I know like
the TTS. Yeah.
okay, yeah, because the main Siri part, a lot of it is still like old, like not even neural networks. That's what I heard. It's like symbolic, like 2000s AI.
It's going back to the old meme with AI is just a lot of if statements.
Yeah, like literally,
What do you
yeah,
mean?
like literally original series, like a bunch of if statements, yeah.
The original Siri was parametric speech synthesis, but they switched it in like 2017 or something.
Yeah, I'm talking about like the not the speech synthesis portion, but the actual reasoning engine, you know.
I see where
Yeah.
this is going. We're gonna get reasoning, and just gonna have models outputting a bunch of structural JSON with if and else statements with themselves.
Yeah, actually, we know that they have really efficient multimodal models and voice models because they, just like in the past year, they released two accessibility features and they probably release it for accessibility people because they're like, let's at least let the disabled people use this early. So they have something where if you're losing your voice, you can just like read like 10 minutes worth of lines on your iPhone, and then it actually creates something like that could speak in your voice that you could speak to people later on if you lose your voice. And then they also have a thing where if you're blind, like, and as far as I know, this all runs locally on the iPhone. Like, if you're blind, you could point your iPhone at, like, let's say your microwave, and it'll tell you like microwave, like your microwave's in front of you, but you could even point your finger at like let's say the number one or like the steak button, and it tells you immediately like your finger's over the steak button, your finger's over the one button of the microwave, and it's like this is actually practical stuff, and it shows like pretty precise like multimodal abilities that's already running locally. So just a matter of integrating that into like full reasoning engine and full system.
So I was going through the financials of nVidia, and by the end of the year, nVidia and Apple are going to compete with free cash flow altogether. So that's going to be a crazy one.
You're saying like they'll have the same amount of cash on hand?
So like Nvidia is expected to have $26 billion, $26.9 billion, and Apple is declining. And right now, as the report is like around 98 billion. But in 2023, as of December, is 37 billion. So it's gonna get pretty wild now with Nvidia. And Nvidia apparently put some crazy presentation saying that they will reach 1 trillion in market opportunity by 2029.
That's free cash flow. So that's actually just like what they create through business, not what they have in store. And Apple is big on that because they just keep a lot of their profits from Europe and all of that outside
Yeah.
the US, so they don't have to pay taxes, and then they get it back to invest in R&D.
What's even wilder is Nvidia's data centers is probably 78 to 80% of their revenue right now. So consumer product is not growing as fast. I don't think they're going to focus anymore as much on consumer, except for like gaming GPUs and stuff.
Yeah. It's actually like a pretty good deal. Like, I mean, I'm, the creator of GGUF and GGML, Georgi Gerganov, like he does a lot of his development on like an M2 Ultra Max Studio. And I'm considering getting one myself because it's just like it's already without these huge operating system upgrades that we're like speculating about. Like even without that, it's a good deal. Like you could already train on it without MLX, with a lot of current training frameworks. You can like do inference on a lot of different apps already really fast. Like, yeah.
I mean, to add to your point, I think when Grok from Elon, when he dropped out all the models, everyone think like, how can we run it? And it's about like what, 300 gigs already. So yeah,
Actually, if you do it like I mean, a lot of people run models these days at like 4-bit, which if you run Grok with that, like it actually can fit already on the current M2 Ultras, which like you need at least I want to say at least like 170, 180 gigs to run Grok with a K, Elon's Grok,
yeah,
and you can get up to 250 gigs on the Mac Studio right now.
yeah. Maybe I feel like it just everyone like, yeah, well, maybe it's not even worth it. Like I don't think the challenge is not that.
Yeah, it is gonna be not that fast, yeah, but I mean, actually, since it's a mixture of experts architecture, though, it'd actually be around the same speed as like a typical like Llama 70 billion parameter model. And so I think that can already do like yeah, it would be like at least 10 tokens a second that you could probably actually run Grok.
Right? Yeah, yeah. It'll be around there. Yeah, you're right.
Yeah. Pretty insane though. I want to see who's the first person that's gonna upload a video of Grok running on their Mac. That'll be
Dude,
funny.
isn't Grok already running at 10 tokens a second on the API?
It might be, yeah. So I
I'm pretty
guess
sure it's like 10 or 12.
maybe, yeah. So in that case, your Mac will be running it like about as fast as the API.
That's right. I
Yeah.
think that's why like maybe Apple is trying to position themselves properly in what to sell. So if it's they have the entire stack, it doesn't make any sense to use any cloud service for just inference. It can be done locally. And I think that's why they're probably targeting it. They can flip the entire coin, then probably Nvidia stock will go down for sure.
I'm gonna head out. It was great talking to you guys. Bye.
Yeah. Good night, guys.
All right, see you, man.
I think I can get Grog down to run good on 48 gigs, like less than 48.
Less than
I'm gonna
48.
yeah, I'm gonna try slurping together the MLPs. This is gonna probably sound like gibberish to people.
Oh, apparently, actually just yesterday, I want to say, Apple acquired an AI startup that has some big researchers in it, apparently.
They've acquired 31 AI companies in 2023 alone.
Yeah, well, this one, like, apparently it's making bigger waves because it's like an especially significant one. This one's called Darwin AI. I haven't actually personally heard of it, honestly.
Oh shit! Yeah, yeah, I know Darwin.
Um,
Yeah, Darwin is a Canadian company actually.
yeah, yeah. Shout out
And,
Canada.
and yeah, they've been around for since the like first deep learning wave. Mostly focusing on like uh I fuck I don't even remember, but like they had like a lot of work in I think medicine and like evolutionary AI and like interpretability research and so on.
Yeah, apparently they have a lot of tools for interpretability and like actually remember OpenAI recently released the open source Transformers debugger thing. I don't know if you guys saw that. But I imagine like apparently what Darwin has been focused on is like a bunch of stuff like even better and larger scale than that. Here.
Yeah, they've been around for a while. It's interesting. Actually, even the Apple Vision Pro was like that was a Canadian company they acquired that helped them like actually get the technology they needed to actually build it.
Yeah, apparently, it says they're focused. Darwin AI. I mean, this is still kind of vague, but it says their research is largely focused on making AI models smaller, faster, and more efficient to run on edge devices like cameras or robots, rather than relying on cloud computing. And then their other core technology is explainable AI that could analyze visual data and yeah, pretty much interpretability stuff. So, I mean, those are the two things Apple actually probably desires most is like better interpretability and more controllability, and then literally just making it more efficient and smaller. So it seems like the perfect startup for them to buy it. Have you heard of them? Like is that pretty much like the like how long have you known about them?
Oh, I've known them for a while because I was uh, I knew them from this thing called the Creative Destruction Lab in Toronto, which Dave. Um, and
Mm.
like Darwin AI was, I think it was either one of the companies that went through the program or their founder was there. I don't remember entirely, but it was years ago.
Hmm.
Uh, I don't know. It was like probably close to like 8 years ago.
Oh, they have researchers from Waterloo. That's a big buy signal. Waterloo.
Yeah, Waterloo.
I'm looking through their info now.
Man, our government is so dumb with all these grants. Like they need to take equity from these startups they're funding because
Then
like,
they wouldn't take the grants. Like no one would take those grants if they take equity.
I mean, if they give me
I wouldn't
100
take a
grand,
grant. It's no longer a grant, you know.
I think
True.
plenty of I think kids have been so VC pilled that
are
they would do
are
it.
are you are you basically following Nat Friedman's playbook of calling it a grant but actually taking equity?
I it's basically basic income. Like that's what it is. It's just can't make profit.
I
You
grant
like
you money,
Yeah,
you grant me equity, right?
uh,
anyway, good space. I'm gonna head off. This was interesting. We
Hey,
need chip
Niston, I heard
reports.
you really like the new NVIDIA cards.
Yeah, I went on a rant about them. They need to bring the prices down, and that's
wait, do we
like
know what the prices are though?
I think you can take an educated guess at that. Though they're gonna be they're gonna be high.
It's just kind of funny how we're talking about like we hope they bring the prices down, but we don't even know like what the new price is, right? Like I don't know. I feel like
I,
they might end up being only 50K. Who knows?
I mean, like they should be cheaper, but anyways, who cares? Like let let's just get more compute, more hardware, fucking accelerate.
Well, do you
getting
guys think that
PI.
this will allow OpenAI to reduce like the token like or sorry, reduce the price per token pretty much?
I no, but I think I think look uh like in terms of inference, like it's not going to really have an impact. But in terms of training, like training new models, that's where the excitement is. Right? It's like that's what this compute is going to affect first, right? Like the people who are buying this compute are not buying it to host like
But
models
you could
for.
probably fit one inference instance on fewer cards with these, as if you have way more
Yeah,
memory.
sure, but you have the other compute to do that too, right? So like you're not gonna buy this brand new chip to like
No,
host
but the question was
multiple.
whether it's possible to reduce pricing with that, and it's definitely would make it cheaper.
Oh yeah, but like when is it gonna actually get into like your hands at that scale to actually reduce the inference costs, right? Like that's gonna take some time.
Yeah, but was that the question? Not,
Yeah,
Yeah,
but
I
well,
think that
also
was the
keep in
question.
mind like the previous supply doesn't go away, right? Like it could actually just be cheaper because they're trying to squeeze every ounce of it before it's taken out of commission.
I was hoping it's 3 nanometers, so it brings the H100s down in price. That was my main
But why
hope.
should that to bring them down in price?
Because there's just more on the market. The only problem is there's just not
Uh,
enough cars on the market.
I don't. Is there spare manufacturing capacity on 3 nanometer? I assume that they also use all of that. No.
Yeah, Apple used it, but overall, you look at again the 4090 versus the H100s, and the markup in price for what you get for inference is way higher. Now, yeah, this will actually help a lot with the running parallel processing and tensor parallelism in inference, because you make a lot more copies of the same one in batch process. But if a new process node came, it would just automatically bring down the price on the other ones. Like it just wouldn't be as stratospheric as it is. 'Cause right now, it's just ridiculous.
Yeah, but it's not because of the price. I mean, the price is because they set it that high because they want to make a lot of money. It's not out of the goodness of their heart. I mean, they could reduce it if they wanted to. I really don't get the point. They have a quasi monopoly and they're behaving like that.
Yeah, that's not
And
good.
expect them to behave like that for the next like 5 years or so, 10 years maybe until someone else can compete.
No, I think the thing's gonna happen a lot sooner.
Yeah, I agree.
So yeah.
It's gonna happen very very faster. I think there is so many fabs, so many like ASML is working on the DUV, which is like the mm, more than the ultraviolet one. It's pretty much
No,
accelerating.
DUV is your old process.
Sorry, DV. So it's
EUVNA is the
that's
new
right. Yeah.
process.
So they are
Do
actually like
you think China's going to be able to catch up though?
if you are a
Dude,
small
you guys
team,
are
if you
conflating a
are a
bunch
small
of
team,
different things that.
yeah.
Why should it's not that the H100 cards cost what they cost because Nvidia wants to make money, not because they're expensive to make. What has that to do with ASML?
Well, I mean, like to be fair, it's like the real answer is yes, they want to make money, but it has to do with the limited capacity of the chips, though. Like because they could the only reason why they could charge such high prices is because there's like such a high demand relative to the capacity that they could provide. Like if you only have one cookie and a million people want to buy your one cookie and you can only provide one cookie, then like you could afford to, charge like $1 million for that cookie or whatever. So as
But
ATMC,
no other manufacturer has figured out an as good combination of hardware and software currently as Nvidia. That that's what I mean with Nvidia has a quasi monopoly on this.
yeah.
Not that there was someone else who could just make a fuck ton of cards if they just had like another fab.
Sure, but I mean, if nVidia could provide like had 1,000 times more GPU supply than they currently do, or like they could have that much more supply, then they'd probably charge cheaper costs for each because the amount of demand relative to the supply they have wouldn't be as much.
Yeah, that's right. You increase competition, it should in parallel introduce the cost.
But there is no competition, and nVidia doesn't drive down their own prices. Or at least no real competition. I mean, there are like the pretty expensive to make AMD cards, and I think Intel's Gaudi cards are also pretty expensive.
Well, like there's a reason why.
nVidia happens to have a very good product. That's the point.
Yeah, but there's a reason why the consumer cards are only so cheap because of the fact that the demand relative to to supply is not as high.
Why are we switching to consumer cards as part of discussion now? I don't get it.
Never mind. Never mind.
That semi-analysis article from this morning that got removed did say that they're forecasting their margins to go down, except it said from 80% down to like 70%. So maybe it is going down, just a little bit.
Yeah, I think you naturally end up having like companies like, let's say 3 years ago, that had a ton of money, like cash on hand. Like, they're dumping huge amounts of their cash on hand to buy a bunch of these GPUs as much as they can for the servers and for training. And like, obviously their cash on hand goes down over time for a lot of those companies, and then the amount of demand they have for future generations of GPUs aren't as much. It's still going to be stupidly high though. That's probably why it's going from 80% margins to 70% instead of like 80% to 40%.
We're all gonna make it.
Yeah, we're all gonna make it. We're all gonna make it. We just need to train.
Just need more GPUs to make it.
We need more GPUs. We need to train some fucking killer models.
The company Grok released a press release now just saying we're still the fastest. That's it.
What you did, or are you?
Based.
Now on their Twitter, if you press the link, it just goes to their press release and still faster.
Not for long though.
Yeah.
It's an extremely interesting time because I never thought before that. Like I always thought exactly like everyone else. Not that long ago that they have all the talent, they have all the compute. You can't possibly compete. Yet here we are. Google can't make a 7B. Grok sucks ass. I mean the model.
Yeah, I mean, Grok. I'm sorry, Gemma 7V only like is only beaten by Mistral by a little bit. Okay.
Have you used it, dude? Like,
No, I have not. I'm not have you. Is it really
yeah,
bad?
I did for like 2 days. It was I didn't use it enough to actually know. We'll see how that open chat fine tune does. But yeah,
I just saw it. Grok Cloud. They just added Gemma. So that's new.
Yeah. Did you manage to get Grok OpenAI's XAI's Grok running or not?
No, that shit is too big.
Yeah. No, listen, you were downloading it. Did you get it running?
no, I didn't bother because I didn't just want to keep a giant machine on just to download it. I'm planning to do either an expert merge or slurp together the MLPs or just chop them off. I'll see, and then that should bring it down to like 86B, and then that should be able to run. I'll have to do the trick where you switch the gates to always just activate the first two. I have the GitHub for it, and so then that would
So
be
why
86B at
bother?
8-bit.
Why
And then
even bother with all this?
no, I just want to get down to running
Okay.
in 242. Like, yeah, it should be able to run with just 43 gigs. So it should be able to run with two 24 gig cards. I just want to prove
Yeah,
it and
but
stuff. I'm not gonna actually train it. I'll let.
okay, so you're gonna do all of that, and then the performance will go down because like after you butcher it, it's
Not
not gonna
really.
be as aligned.
I don't think it's gonna really go down that much.
Oh, it will. It will.
Do we know the performance now? Like, how is it compared to other LLMs?
Yeah. There's some benchmarks that were posted. It's not that great. It's like it beats GPT 3.5 by a margin. But yeah. Again, those are benchmarks, like the MCQ benchmarks. So you can take them with a grain of salt.
Why is it so hard to find like just a simple chart and side-by-side comparison of the important specs of H100 versus important specs of B200? Like, I don't know if I'm just so spoiled from like AI search things, but I'm trying to use Google and it's just like I'm somehow not able to find this, like what I'm asking for.
It's impossible to find the same specs for all the NVIDIA cards. They always use different tables, different metrics.
Well, yeah, but like somebody must have watched the NVIDIA like keynote and then just put these into a chart, right? Like,
The past 1 hour, I've been trying to get the video to text of the keynote so I can put it in my LLM to figure that out, but it's impossible. It's a 2 hour long video. I'm splitting the video. It's
because
such a pain in the ass.
you can take like, I mean, there are things you could directly compare because there's like the memory bandwidth, that's an important number. There's the like FP8 or FP16, teraflops a second. You could compare that. There's the amount of memory total.
I thought NVIDIA would publish those graphs in the investor relationship, but they haven't. So there's no fucking way to get those tables.
I found a chart at least showing H100 versus B200, but I don't even know why they wouldn't include B100 in this chart.
Because B100 is the HBM3 card that's faster, and that looks better for them.
Well, yeah, but I'm not. This is not even an NVIDIA website. Yeah, this is like a journalist website that I would expect to do a one-to-one comparison.
Okay, so tomorrow they have a GTC financial analyst Q&A, so they might disclose more there. So I'll try to get the transcript of that and see if they say anything. Actually, it's a 7-day long Q&A.
They have a session specifically for financial analysts. Yeah, NVIDIA's Hollywood. They made it.
Literally 7 days. It starts the day, and then it goes Tuesday, Wednesday, and they have released like different topics for analysts to start asking. And they have all these smart people, like head of departments, basically leading this Q&A. That's interesting. Never seen that.
Felix, have you heard about Felix? Have you heard about the light matter?
No, what's that?
Yeah, it's another AI chip. It's
Photonics.
photonic one.
Hmm.
Oh, I heard about the concept. Yeah. Okay, photonic. Yeah, but I haven't read
Is there
in
something
detail
special
anything
about
about
this
it.
specific photonic hardware?
Speed.
The idea is you can route in different frequencies on over the same data path, basically,
Are
or
you
the
talking
same
about
wire.
general photonic benefits or this specific company? Yeah,
General
so
photonic.
yeah, I understand the
That's,
benefits
that's
for photonic
the
computing. I
benefit.
mean, like, is this specific company doing anything better than other attempts at photonic?
Yeah, no clue.
Only handful. There's only 2 companies that doing this at this large scale. Yeah.
What's the
What's the name of
company
those?
I
called?
feel like I've
What's
heard
the
of
company
at
called?
least 3. There's Light Matter. There's oh man, what's
There's
the other?
Talas, which is
Oh,
also here in
true. There's
Toronto.
the last. Wait, what is the other one?
There's Xanadu. Xanadu.
So that's at least 3. Xanadu, Talas. There's like at
Also a
least.
Canadian company, by the way.
There's
Just
also
Talat and Xanadu are Canadian
also
too.
Cerebrus office, design office is here too.
Yeah.
Yeah,
Yeah.
yeah. Just so you know who's boss, right? Like, just so you know who's boss.
I think Xanadu is
Oh.
maybe the main one I was thinking of.
Yeah, Xanadu is was actually like focused more on like quantum computing using photonic chips. Um, yeah.
I talked shit about Grok in the beginning and stuff, but they're doing it. They have the top spot. If if you can beat them, somebody would have beaten them. Nobody has.
Or somebody will beat them in due course. It won't take
Yeah.
long, I think. It's just not profitable to run what they're doing, and it's pretty easy to lose money, and most companies don't want that. Or at least limit the amount of money they're losing, and optimizing for latency is a pretty questionable endeavor, I think. For inference speed, not latency,
For training, maybe it makes sense.
because
Maybe it makes sense for training.
it's easy to lose.
It makes
Sorry,
sense maybe for training.
what?
The photonic.
Oh, I thought we were talking about graph
Ah,
cards.
sure.
That which is, I'm not sure about the photonics. Photonics is a completely different approach. I don't think we'll see that in any mainstream hardware soon, because it's so far out from what's actually useful in like high performance things.
You mean
Well,
HPC? Yeah.
for
No, general, yeah. Okay, yeah. We don't usually call it HPC, but like in general data center
Sure.
approaches, I mean, it doesn't matter whether you specifically mean HPC or, yeah. A lot of data centers now considered HPC. Yeah.
Also, light wavelengths are at hundreds of nanometers. So you're looking at this, signal path that's going to be 500 nanometers wide, and with electrons you can go down to 5. So then you go 2D, and then you have, you need 10,000 times more room to fit all that stuff in.
I don't think that's how it works, because you can easily hear in the wavelength doesn't determine whether you can see something necessarily. You can hear in basically audio wavelengths that are longer than your ear is. You don't need actually the resonance room to make it out.
Yeah, you're right. But I think the smallest photonic gates are still at 100 nanometers, if I remember correctly from astronometry. They're still big. Like, they're just big.
I mean, the approach between photonic and the regular chips like nVidia, it's just the fact that you still can't achieve um, a large inference even though you're still at 5 nanometer. That's the difference.
I'm not sure what the last thing was it now meant to state? I didn't get it. What the point's supposed to be?
So for
But
yeah,
photonics.
for the photonic, the main advantage on comparison with regular chips like NVIDIA going through like the 2D, 3D kind of layout is the difference is that you can achieve the same output at 5 nanometer compared compared to all NVIDIA. They're trying to go down more in the nanometer so they can just stack up more transistors on. However, like the photonic ones, you can do that. You can achieve that at 5 nanometer, and that's the difference.
No,
But we can already build chips with feature size of 5 nanometers.
Yeah, but then the inference part. That's what probably that maybe I left it out in the conversation earlier is that the inference part is very faster at the photonic one. That's what's in compare.
What do you mean? Do you just mean that the signal time is faster in air than in wire?
No, not the
Is that
wiring.
what you're saying?
So the speed of transfer in that sense, since it's photonic, the speed transfer between the chipsets, they are very low latency by design.
oh, you're
So
talking about networking stuff. That's they already use the photonics chips as network cards in between chips, and I think Intel did it on the same board. But
yeah,
they
they
don't.
did.
Isn't that just optical fiber?
Yeah,
That's
it's just like
completely normal.
integrated fiber. Yeah.
So what that does is the yield of that is that it have low fab cost because it's still at 5 nanometer. Compare like they're trying now to squeeze as much as they can, like going down three nanometer.
The photonic chips are way bigger. Now I don't know what the limit
No,
is,
the
but I
passage.
think it's around 100 nanometers, like way bigger.
I think the passage one from the light matter, maybe the last like in use on them, it was about 5 nanometer.
Well, either way, the wavelength of the light, like I feel like it doesn't matter too much in terms of like you can have things on the order of like 5 nanometers from light that's like a wavelength of 80 nanometers or whatever, because that's what they do already with like the actual fabrication of like TSMC chips. Like the ASML machines are producing light at like sometimes over 100 nanometer wavelength, but they actually are able to produce features of like sub 5 nanometers because like they use a bunch of smart techniques of having the light overlap in specific ways and like yeah.
The EUV is 13 nanometer. Like 5 nanometer light would be very hard
Yeah,
X-ray.
exactly. Like, yeah. Like even with EUV, it's way
But
higher than
like
the actual
we're
nanometer.
confusing topics. Yeah, I mean, as I stated before, you can actually distinguish light at a smaller feature size, but that's like something different. We're conflating manufacturing and use chip on the chip processes,
Oh,
which
you mean
don't have
okay.
anything to do with each
Sorry,
other.
yeah. I was not fully paying attention, yeah. Wait, so you guys are talking about the light matter chip specifically? Or just photonic in general?
Just photonic chips in general.
Okay.
So the Grok people tweeted a response to GTC saying Grok is still faster.
Yeah, we saw that. I think we posted it on the billboard.
Oh, sorry. Okay, can someone explain to me, like, it kind of bothers me that they call it an LPU. Like, does that imply the only thing this chip could ever do is make words?
No, not really. No, there's nothing specific about words to it. It's
It's
just
bullshit.
it is very optimized specifically to neural networks.
I just feel
I don't think even neural
Well,
networks
yeah,
is
not
just a
even neural
market.
networks, yeah, because
LPU
it's
is
not.
just a pretty recent
Yeah, it's
marketing
not
term.
even like
It's a bullshit name.
it's not even like a neuromorphic chip or anything. It's like it's it's kind of like it's closer to a GPU than it is like a neuromorphic chip, but it's just designed like simpler and in a way where you can like optimize the chip like in the operations like very low level, like much faster on this to like let's say Llama 70B than you can with like a traditional H100 for Llama 70B.
It doesn't even feel like a good marketing move though. Like if I'm a potential customer, I'm just like, okay, what if I want to do literally anything else? And this thing is literally called an LPU.
Like the TPU, for example, is not really like a TPU is not neuromorphic or neural network specific either. But it also has like it's that
But
they
at
also
least it
don't.
doesn't have a particular modality in the name.
True, yeah, they do call it tensor processing unit, and I guess you could say it is, yeah.
It's just LinkedIn talk. That's all. That's all. It's good.
LinkedIn talk.
By the way, I'm trying to add people. I'm trying to add Lars, but I can't. LDJ or Pharrell, maybe you guys can try add him. I don't know. The app's just weird.
TPU is a pretty good name, but you could actually call almost any chip a TPU.
Well, the founder of Grok is basically the guy who started the TPU at Google, right?
He's one of the guys. One of the guys.
Yeah. And like it's funny how they put it like he's the one of the 20% project, the Google shit they have, where like you spend 20% of your time working on a side project. And they literally turned that into a whole story about it.
I don't know, dude. This is kind of a salty post. Like, why? I don't know.
They are still the fastest.
Yeah.
Yeah, it's interesting.
It's like if you make the fastest chip and no one has a chip, it's like a tree falls in a forest. No one, yeah.
But I mean, as far as the end customer is concerned, if you need more than 500 TPS, that's where you get it at batch size 1. Because Alpin did what, like over 7,000 with the 7B on a single 4090.
Yeah, it is.
I don't know, John.
Yeah.
How much do you get out of 4090 on your models?
Like 6,000.
Yeah, there we go.
Christ.
But to be fair, like
Sorry, I'm eating.
You could have a
no
fucking
problem.
spoiler on your computer, dude.
But like with the same like using same model and everything, I think Grok versus like I think you can technically get the same speeds as Grok with like enough GB200s or whatever. It's just a matter of like if it would be cost competitive, right? It's like
Yeah, George Hoss tried to get nVidia or Grok or someone take his bet that he could get Mixtral fast enough, basically beating Grok chips on faster inference on like in full node of H100s, like 8 cards, and I probably think he could
but
probably
then
do
the
it.
thing is, it's like
The math checks out.
well, I think like I mean the cost difference though, like maybe if you're only counting the energy cost, maybe, but the cost
Well,
difference actually acquire the chips. I mean, Grok makes it,
No, it's cheaper to buy H100. You only need 8 H100 cards for
well,
doing
even
that.
then, I'm not sure if even that's the case because okay, let's say you do only need 8 H100s. Say you're getting each H100 for 30K. That's a total of what? Let me just do quick math.
Yeah, and like individual Grok card also costs
No,
30K.
that's
It's
not
not
true.
that much
That'll
cheaper.
just no, that's not true.
Okay, the only price I saw them selling for is
He,
30K. I'm not sure
wait, you actually
where you
saw
can get them
you saw
cheaper.
people saying that, or they actually said it themselves? You're saying?
I saw it on Mauser and I tweeted a screenshot like 3 weeks
Because the
ago of
CEO
that.
himself just said that like that's just like misconception. Their cards don't cost or their chips don't cost anywhere near 20K. Is what he
Yeah, they don't cost them, but I think the only if you want to buy such a chip, it's the only price you can, as far as I know, you can buy them for.
here.
Yeah, A100s are still like 18K on
Yeah,
eBay for an 80 gig.
I'm not sure because I tried to look. If you end up finding a source on that, I'd appreciate it. But yeah, I remember him saying like it didn't even sound like he was saying it doesn't cost them that much to manufacture. He just said flat out like our chips do not cost anywhere near 20K.
Yeah, but the cards do. I mean, you can't buy the chips. They don't sell the
Oh,
chips.
that's a good point. Yeah,
You,
the
you mean
packaging is done
Grok?
outside.
You mean like if you wanted to buy the
If you want to buy Grok, or if you want run Grok in your data center, I think you need to buy one card, several cards at a price per card of $20K.
Yeah,
Yeah,
you
if
need
you
to
have a
buy at
source,
least a node. Yeah, yeah, you need to
if you have a source on that, I'd appreciate it. Yeah, because I don't see any source on that.
If you want to scroll the media tab in your Twitter, but I'll try to find it again myself.
Yeah.
Is that also like how many concurrent user can handle and stuff like that? Just
Grok can handle one, exactly one.
Here. But yeah, from the perspective of like, you know, how much it costs Grok to run or whatever, like, and it's, yeah, like, I mean, if we do the price difference that way, so it's like $500 or whatever, I think it does actually end up maybe being cost competitive against, you know, 8 H100s that would cost 30,000 times 8, which is, that is...
No, 8 100s would be cheaper, that's the point. Grok is that bad of a value proposition that 8 100 would be cheaper.
Here, let me see.
Thing is that per chip at 32 nanometers is gonna be like dollars for the
Yeah,
for
like
the
it
chip
might
fabs to make it at scale.
like it might be like $100 or less,